Please open up your textbook to page 120. We are ready to begin lesson 3.2 on writing expressions. Our purpose today is to write an expression after identifying keywords and using a variable for the unknown quantity. The reason we're doing this is so that you can apply this skill in real-world situations. Okay, so first of all, I want us to think today about some words that represent or stand for different operations. I'd like for you to, in your notes section, just make a little chart that has 4 columns: addition, subtraction, multiplication, and division. And then please list at least 3 or more words under each heading that represents the given operation. So, for example, I'm going to show you what I mean here. For addition, a keyword that I might see in a word problem that represents addition is added to, or maybe I'd see the word plus. So that's the idea that I'm looking for. So pause the video, add a couple more to addition, and then think of some words that mean subtraction, multiplication, and division in a word problem. Okay, now that you've completed your table, let's talk about what some possibilities could be. In addition to the ones we mentioned earlier for addition, we could have sum of, more than, increased by, total of, and the word and. All of these words represent addition in word problems. Now, these are not the only words you could have. You quite possibly have a few others that aren't listed here. Some of the possibilities for subtraction include subtracted from, minus, difference of, less than, decreased by, fewer than, and take away. Multiplication, we could have multiplied by, times, product of, twice, and of. And then finally, for division, some possibilities include divided by, or quotient of. Now, this is not meant to be an exhaustive list of all possible words. It's just some ideas to get you thinking about different words and what they mean in math. Okay, so now we're going to talk about how does this relate to the algebraic expressions that we talked about yesterday. So, for example, if I have the phrase x increased by 10, I need to think about what operation does increased refer to. Now, increased refers to addition. So, x increased by 10 simply means x plus 10. What we're doing here is taking a phrase and writing the algebraic equivalent of that phrase. Here's another example. X decreased by 5. So what I want you to think about this time is, what does decreased mean? The answer is subtract. So this phrase would be x minus 5. Okay, the next example is the sum of x and 1. If you think about what sum means, it does mean add. So the answer to the sum of x and 1 would be x plus 1. Difference, here's our key word. Difference means subtract. So the difference between x and 8 means x minus 8. Okay, now I want us to think about the order that we're writing our phrases in. And think about, let's addition first. If I have an expression, does the order that I put my variable and constant matter in addition expressions? Hopefully you answered no. Now what this means is if I was adding x plus 8, I would get the exact same answer if I was adding 8 plus x. It doesn't make any difference which is first and which is last. when I am adding. Okay, so right here is another example. They have the sum of x and 8 and the sum of 8 and x. Once again, it's the same thing. Either way, it simply means x plus 8 or 8 plus x, and I will get the same answer. Okay, now let's talk about subtraction. If we are subtracting, does the order matter? In this case, the answer is yes. What we mean by that is if I'm finding the difference between x and 11, that means x minus 11. And then the other example, the difference in 11 and x means 11 minus x. These two problems are not the same. Now, unless x equals 11, I'm going to get a different answer for these two math problems. So in subtraction, order does matter. You must keep it in the correct order. Okay, now, when we were talking about different terms yesterday, we talked about a coefficient. The coefficient is any number that is right in front of the variable. So for example, if I had 3x, x is my variable, 3 is the coefficient. It's the number that I'm multiplying it by. Now, when we have variables and coefficients, we always want to put the coefficient first. So if I was multiplying x times 3, it's actually more appropriate to write it as 3x. We want the coefficient before the variable. Now, I do realize that I'm going to get the same answer either way. So technically, you're not going to get an answer wrong. But in algebra, the more appropriate way to write it is with the coefficient first and the variable following it. So in this case, once again, the product of 3 and x means product is talking about multiply. So it's 3 times x. Now, one thing I want to mention is if I put a coefficient right beside a variable, it means times. You don't have to go through the extra work of putting the raised dot in between. And this is also a reminder that we do not use the x symbol for a times sign. If you look at my second example here, it looks like 3xx when it really should be 3 times x. So I want you to remember that you cannot use an x in this unit for a multiplication symbol. So 9 multiplied by x, I could write 9 times x with a raised dot. I could just keep it simple and write 9x. We also talked about if you have a number right beside a parenthesis, it means multiply. So any of these 3 answers are correct, but you once again would not do 9 times x with the x symbol for multiply because it looks then like 9xx. Now, of these examples, the best one is 9x. We just want to keep it simple. We don't want to do any extra writing of symbols that aren't necessary. Okay, so the product of x and 15. Remember I mentioned a little bit ago that when we're dealing with multiplication, the coefficient should come before the variable. So even though x times 15 would mean the same thing, the better way to write this would be 15x. Product of x and y. The same is true when we have 2 variables. We can write them right beside each other. Now, if you wanted to put a raised dot in between them, that would be fine. If you wanted to put the parenthesis, that would also be okay. But if we just wanted to keep it simple and short, the easiest form is to just do xy. Okay, now in this example, it says the product of 24 and a number. Now, we don't know what that number is. So, what can we do? This is a perfect example of when we use a variable, because that variable stands for a number. We don't know what the number is, so that's why we use the variable. So the answer to this question, the product of 24 and a number, would be 24n. Now, they don't tell me I have to use n. I just chose n since n is the first letter in the word number. I could have done 24x. I could have done 24 times z. It doesn't make a difference, but in this case I chose n. Okay, now this is actually just a repeat of what I just mentioned to you. The number refers to the variable, and the variable is unknown, so it can be any number. Okay, here's another example, twice x. We need to think about, what does the word twice mean? If you think you know how to write this expression out, please put it in your notes. Okay, the word twice means 2 times. So how I would write this expression is simply 2x. Our next example is m squared. Now squared is a little bit different. Think about what m squared would mean. Okay, this is what m squared would look like. And if I have an exponent of 2, that simply means m times another m. So either of these answers would be considered correct. Okay, finally we're going to talk about quotient. The quotient of x and 6. We need to think about, what operation does quotient refer to? It would be division. So I need to divide x and 6. I have several options. I can write that out as x divided by 6. I can also write it out like this, x divided by 6. Remember, a fraction bar is just a way to write divide. A third way I could do it is x divided by 6. A slash mark also means divide. Now, a way that we would not write it, and this just isn't done in algebra, is we would not do x with the bracket for divided by 6. We don't put variables into the division bracket. So this way would not be acceptable. Any of the other 3 are. Now you're going to see me try to use different examples just so you know you can mix it up. It doesn't matter whether you use the division symbol, the fraction bar symbol, or a slash mark. But please do not put variables inside a bracket. Okay, now does order matter when we're doing quotients? The answer is yes. Think about it this way. If I have 1 divided by 2, my answer is 5/10. If I have 2 divided by 1, my answer is 2. 5/10 is a very different number than 2. So yes, order does matter in division.